Hey, what's up guys? My name is the Cherno and welcome back to my C++ series. Today, just coming at you with a quick video and we're going to talk about what static means in C++. So the static keyword in C++ actually has two meanings depending on what the context is. One of those applies to when you use the static keyword outside of a class or a struct, and the other is when you use static inside a class or struct. Basically, just to cut to the chase, static outside of a class means that the linkage of that symbol that you declare to be static is going to be internal, meaning it's only going to be visible to that translation unit that you've defined it in. Whereas a static variable inside a class or a struct means that that variable is actually going to share memory with all of the instances of the class, meaning that basically across all instances that you create of that class or struct, there's only going to be one instance of that static variable. And a similar thing applies to static methods in a class. There is no instance of that class being passed into that method. We're going to talk a lot more in depth about what static actually means in a class or struct scope, so definitely check out that video. There'll be a card on the screen and a link in the description below. But today we're just going to focus on what static means outside of that class or struct scope. So let's dive into some code and take a look. So what I'm going to do here in this completely empty C++ file is just define a variable to be static. I'm going to use the s underscore convention here to basically indicate that this variable is static, and I'm going to just set it equal to 5. Okay, cool. So it looks like any other variable, but it's got the static keyword in front of it. What does that actually mean? What it means is that this variable is only going to be linked internally inside this translation unit. If you don't know how C++ compilation or linking works, definitely check out my videos on how the C++ compiler works and how the C++ linker works, because you really need to understand what's going on there to understand this. A static variable or function means that when it actually comes time to link those actual functions or variables to actually defined symbols, the linker is not going to look outside of the scope of this translation unit for that symbol definition. Yeah, again, this is one of those things that's best explained by example, so let's take a look. We've clearly created a variable here and set it equal to 5. Let's go into another C++ file, into another translation unit. Here I've just got a blank C++ file with a main function. We're going to create a global variable here. I'm going to give it the exact same name as the static one, and I'll set this equal to like 10 or something like that. If I try and print this variable, you can see that we can compile our code and we're not going to get any problems. And if I run my code, of course, we'll get 10 printing out to the console. However, if I go back to my static.cpp file and I remove the static keyword and I try and compile my code, you'll see that when it gets to the linking stage, we actually get a linking error, because this s variable has already been defined in a different translation unit. So we can't have two global variables with the same name. One of the things I could do to fix this is change this variable to actually refer to this one. And the way that I can do that is by getting rid of the assignment here and marking this variable as extern, which means that it's going to look for that s variable in an external translation unit, which is called external linkage or external linking. If I run my code now, you can see the value we get is 5 because of course it's referencing this s variable. However, if I come over here and I mark this as static, it's kind of like declaring a variable private in a class. No other translation unit is going to see this s variable. The linker will not see this in a global scope, which means that if I go back here and I try and compile my code, you can see that we actually get an unresolved external symbol s variable because it cannot find an integer with the name s variable anywhere, because we've effectively marked our variable as private. If we go back here, I'm also going to declare a function to show you guys that it does the same thing. If I declare a function here called function, and another function over here which has the same signature, is also going to return nothing. It's going to be void. If I try and compile this now, I'm going to get a duplicate symbol error at the linking stage because there are two functions. If I go over here into static and I mark this one as static, then of course when the linker starts to link all this, it's not going to see the static one, and thus I'm not going to get any errors. Let's try and compile this. You can see I don't get the error anymore for the function. I still get the s variable one. Let's just get rid of that. And the print as well. If I compile this, we get no errors at all. So that's really all that static means when you use it outside of a class or a struct in C++. It just means that when you declare that static function or that static variable, it's only going to be visible to that C++ file that you've declared it in. If you were to declare a static variable in a header file and then include that header file in two different C++ files, then effectively what you've done is what I've kind of done with my example, where I've had that same s variable declared as a static variable in both translation units. Because of course, when you include that header file, it's going to copy all of the contents and paste it into that C++ file. So what you've done is you've just created a static variable in two different translation units. As for why you would use this, think about why you would use private in a class kind of environment. You basically want to use static as much as you can if you don't need the variable to be global, because as soon as you start declaring things in a global scope without that static keyword, you can see that the link is going to pick it up across translation units, which means that you've created a variable that is completely global. If I create a variable with the name variable and it's in a global setting, suddenly that name variable is completely global and can be used anywhere, and that can lead to some pretty bad bugs. And that comes down to the whole saying that global variables are bad, which I don't particularly agree with. I'll probably make a video about that in the future, but the point is, try and mark your functions and your variables static unless you actually need them to be linked across translation units. As I mentioned earlier in the video, if you want to know more about this in a class or a struct setting, click on the screen and you'll be taken to that video. But I hope you guys enjoyed this video. If you did, please hit that like button. Let me know what you think in the comments below if you want any kind of clarification. You can also follow me on Twitter and Instagram. Links will be in the description below. If you really like these videos and you want to see a lot more of them, you can support me on patreon.com/thecherno. If you do that, you'll also receive early drafts of upcoming videos, as well as a nice kind of group discussion where you can talk about what actually goes into these videos and requests, topics, and all of that fun stuff. Man, I was out of focus the whole time, wasn't I? Great. But anyway, I'll see you guys later. Goodbye.